Although the pyramids were made quite accurately, and they were made with measurements that seem to be consistent no matter where you go, the truth is the ancient Egyptians had multiple ways of measuring, and they used multiple methods. We know that in farms, they used to use strings and also the 345 method in order to measure someone's property. One of the ways that they documented and tried to standardize the way of writing was to create rulers. These rulers basically took the rough measurements that ancient Egyptians used to use and tried to create straight lines so that people did not have to use different measurements, especially since the measurements they used were so natural and could vary on each individual, especially if it's a male or a female. So let's start with the explanation of symbols. See, in ancient Egypt, they did have a type of writing that was for nobles and the people at the top, but something they did not forget was the ordinary person. Remember that the Egyptian houses and the Egyptian structures were designed for the average person, meaning if it has no meaning to the average person, then why would they care? Why would they even value the structure and not destroy it the first chance they get? And so, even the people who could not read during the times of ancient Egypt, and I put a asterisk on the word read there, but even the people who couldn't read should get something from the symbols. In measurements, for example, if you ask someone today what's a centimeter and how does that relate to a person, I'll give you an example. If you go to a shop and you try to buy a piece of fabric by the meter, they will grab the fabric and they will stretch it from nose to tip, and that will give you the general amount. This is what was happening in ancient Egypt. The measurement you get from doing this, stretching of the hand and touching the nose, is roughly 1 meter in most human beings. But as you can guess, this is not accurate. And a lot of Egyptians did this too. They got an inaccurate amount. And if you go and check with modern rulers, you will find it to be inaccurate. It reminds me of an episode of Ancient Aliens where one of the people put down a ruler and said, "Look at these straight lines." And clearly the lines weren't straight. If you go and check things in Egypt and ancient places, they're not as straight as they appear in a picture. But with standardization, things got straighter. Now, the problem with a rope rather than a ruler is that sometimes rope can become slack. And if you don't realize that they're not fully taught, you could be getting an incorrect measurement. Now, of course, rulers have a problem because some people will measure at a different angle and it will seem like the same, but it's different, which is why people use lasers and they use levels and all kinds of items to make sure that you have the exact same measurement. These, of course, did not exist in ancient Egypt, and therefore there was always going to be a problem. But for most problems, there are solutions. Now, remember, not everything in Egypt was measured. Some things are accurate simply because of the method that was done. For example, there are some jars which appear to be smooth to some conspiracy theorists, but in real life, all they did was put sand inside of a jar and then start sanding for stupid amounts of time using rotation methods. This rotation method would always give you accurate numbers, but in real life, it does not mean that they actually measured it in order to get those numbers. There's several of things that we have today which are not measured but seem accurate, including pottery, by the way. So let's look at this ruler. Now, this ruler has three things on it. And like I said, there's always three people that they have to communicate to. One, the educated. 2, the uneducated, and 3, the gods. Now, if we zoom into the ruler, we can see here that it says one finger, and at the top you can see this Horus. So, to someone who couldn't even read hieroglyphics, they would notice that that's a finger, so that measurement is a finger. The second measurement is 2 fingers, and the third measurement is 3 fingers, which, by the way, this is ridiculously accurate. Now, it's not the most accurate, it's better to have a standardization, but it's about accurate. Then you can see that after the fourth, the next measurement is to use your hand stretched, so your palm. The difference between the palm in the first one and the second one is that you have to extend your fingers. And then again, you get another measurement. And then the next measurement, you have to ball your hand in a fist. And when you ball your hand in a fist, it creates another extra finger length. And you can see as you go on the ruler, they keep having more and more of these measurements. And again, it's so that you can understand it if you're a normal person. If you look at the next part of the ruler, they start to go a little bit complicated. So, for the people in the middle who are going to understand it simply, an arm's length, that's called a cubit. That's the first measurement they're going to use. And you can see at the bottom that they give these measurements using symbols, well, numbers, tallies really. And all of these is 1 to 10 to 20 and all of those. But again, if you're a normal person, you don't need this. You just use your arm. When you put it on, it'll be just about accurate and you'll realize that you're on the right track. And a lot of these people were working on the buildings. Now, there are several problems that you could have by yourself if you were trying to measure things in the past. As you can see, the cubit is half the hand, or what they call the forearm. So from the fingertips to the elbow, this would be the measurement of a cubit. This means if you double this measurement, what do you get? Now, remember what I told you in the beginning. If you stretch your hand out today, what will you get? A meter. So a cubit must be 1 meter if you double it. Now, there are a lot of benefits to doing this process this way. One of them, of course, being the fact that you can just quickly, okay, let's do this. Okay, that's how big it needs. Oh, and in other words, you don't need extra resources. You're using your body. It's like that innovation that Steve Jobs had, saying that you don't need a stylus, just use your fingers. Who needs a stylus when you have your own fingers? And who needs a ruler when you have your own body for measurement? It might be accurate to a degree, but every time I measure 2 cubits with my own tape measure, I get about 0.9. So in other words, I get, 10 centimeters short. But if you expand it too far, you're going to get a little, a couple centimeters too long. But it's better to get a close approximation than to get a far approximation. But remember that this is still an approximation. In real life, what you want is something a little more accurate, like the ruler. One of the comments that I got yesterday was Egypt was the founder or was the starter of these civilizations. And that's actually the point of this, that we're looking at it like, oh, yeah, of course, this is how you measure, this is how you do this is how you do that. But remember, they're not looking back at another civilization and saying, oh, they made these mistakes and these people made those mistakes. They're looking at themselves as the originators with no reference in the past. Today, of course, we have ridiculous accuracy. We can even use atomic scales for measurement. But back then, back then they had no idea. Even something as simple as a tape measure was an invention. Even something as simple as a ruler was a invention. There's actually a ruler they have that used to fold, and so it would measure 1 cubit, and then you fold it, and then it would measure basically what today we call a meter. Now you're probably thinking, well, wouldn't that create standardization? Well, the problem is there's actually more ways in ancient Egypt to measure the cubit and all these other types of measurements. So, for example, let's take the cubit itself. And you can try this. I promise you, it will be roughly accurate. If you stretch out your fingers in the same way that this picture is showing, so take the span of your thumb and your little finger, and if you put it on your elbow all the way to the bottom of your hand, so the bottom of your palm, what you will find is that that will be roughly the size of a cubit. Now, there's obviously a problem, which is it doesn't include your hand. This means you will have a cubit, quote unquote, but it will be slightly inaccurate. But this was a measurement used by ancient Egyptians. In fact, it was great for creating curved lines because if you put your thumb on the ground and then you curve the line with your pinky finger, it sort of works like a compass. So you can write down the line without moving your hand. And there you go, you've got a measurement. This little bit of inaccuracy might not matter if you're building extremely large structures, but it does matter if you are two people coming from, let's say, the same civilization. So, in other words, if you're working on a pyramid, there's no way they would allow you to use one method and then allow another person to use a different method. But let's say you live in Abu, right? And the other person lives somewhere in Cyrene or some other place. They live far away from you. They can both have standardization locally, but they don't have standardization internationally, which means when you bring people back or you take workers from a completely different area, you're going to have to re educate the people. And you don't want to be able to do that. And of course, we know that ancient Egyptians, in some cases, even used foreign workers from as far as Sudan to work on their pyramids. How would you need to re educate those people? Well, again, very simple: forearm, palm, fingers. Using this method, you get very, very consistent lines. Another thing that ancient Egyptians realized a long time ago is that the foot is roughly the same as stretching your hand out. So, in other words, the foot, a foot, is roughly from your elbow to the palm. So, if you don't get inside of the arm, so where your palm starts, you stop there. Now, how did they solve these problems? Well, they had different names for different cubits, as we do today, even though people don't really use cubits. So, what are the different cubits? So, a foot would be a cubit because it's the same as the cubit, which starts from the elbow to the bottom of the palm. And like I said, without the hand, it's shorter. And this mistake happened a lot in ancient Egypt, which would make people scrap something and start it over. Now, generally, if you're working on the pyramids, you had the same sizes and even had rulers and ropes that worked as tape measures. So getting the answers wrong really didn't happen. But for the average person who would be working under an architect who isn't as skilled, they would have these mistakes. Today, we use the word a short cubit versus a long cubit, which is what would happen. Now, there's something called a royal cubit, which the royal cubit is the one with your fingers stretched. So that one there, the royal cubit, is that one. The long cubit is from the elbow to the middle of the palm. So it's without the fingers, because, of course, fingers can vary. And then, of course, the short cubit is the one from the elbow to the bottom of the palm or the size of your foot. If you measure using a ruler today, you will find that these are roughly the same, but on different people, it can vary just a little bit. But that small variation makes a big difference after a while. This, by the way, is not something that is unique to them, like I said, with the meter. But let's take something else. If you have normal fingers, maybe you have fat fingers, but if you have normal fingers, place your finger, it should be only 1 centimeter long. Now, we have noticed today that there's a variant, and so some people's pinky finger can be 2 centimeters. Again, if you're a normal person, place your thumb on a ruler or on a tape measure, and what you will see is that your thumb will be 2 centimeters long, almost accurate. But again, you can see why this would be a problem after a while. Also, how are you going to keep putting your thumb next to your thumb just by moving your hand, trying to put the next thumb next to the next thumb will create a giant problem. These same measurements would be great for an artist. While artists in other parts of the world relied on their intuition, the ancient Egyptians relied on measurements, and they utilized these royal measurements on their statues. This is why a lot of them look very boxy. If you notice, there's a lot of boxy like character towards these statues. They look flesh like, but there's actually a lot of boxiness to them. This is because they understand these measurements, and they understand that a foot should be equal to the size of that, and that should be equal to the size of that. And this is where we get when we want to talk about Egyptians trying to measure the earth. Now, we all know that Egyptians relied on their measurements using the natural world. And so, even if you look at the statues, those sizes are not arbitrary. They're based on those measurements, and they all relate to something else. And so, the size of a forearm of a giant statue, go measure it, you will see, will have something to do with the pyramids. This will come back again when we talk about the sphere of the earth. Now, one of the things about the math that was given was that it could measure circles, but not necessarily spheres. I mean, it could, but generally it was meant to measure circles. If the ancient Egyptians used the earth itself as a measurement, the thinking would come from this, trying to understand the natural world. Before I make a video about why a lot of people believe, and probably to some degree accurately, that the earth was known to be a ball in ancient Egypt. Again, this is a big if. Before I make a video about that, I want to lay down one argument on the other side, the devil's advocate argument for why they didn't know. So, people who realized that the earth was just another body in space quickly turned everything in space into a ball, a sphere, realizing that if earth is in what you call space, then the bodies that are in space should also be a sphere. Now, this was believed from ancient times till people developed a telescope. When they developed a telescope, they realized that these bodies in space had mountains and ridges and could possibly have animals and water and seas, volcanoes. This was not known before, which is why one of the reasons why they put Earth in the center, because they assumed it's the most interesting. The other thing that they said was a sphere was the sun. In no ancient Egyptian text is the sun depicted as a ball. Today, if we look at the sun, don't look at the sun. But today, when we look at the sun, we assume it's a ball, and we can kind of tell by looking a little bit, even the moon. But here's the thing: in ancient Egypt, the sun is described as a disk, the Aten. The word Aten literally means disk in ancient Egypt. Now, if we saw some level of understanding of a sphere, we would see them convert other bodies in space into spheres, not just Earth. But we don't see this. They remain till the very end, believing that the sun is a disk, because when you look up in the sky, it looks like a disk. Now, the moon is another one. At no point is it described as a ball or even depicted as a ball. Even when it's depicted in 3D, it's seen almost like a piece of bakery, where it has a 3D element to it, but it's not a ball. It's more of a circle. Now, Khonsu has two things on his head. One is the crescent moon, and the other one is the full moon. There's an importance about this, which is that crescent moon can be associated with two things. One is a boat, and then the other is the cow's horns. This is important because it shows that the ancient Egyptians believed that the moon was literally in different phases, meaning it was not the same moon converting because of light, but instead it was the moon being different, literally. This shows, and I hate to say this because I value the ancient Egyptians, a level of ignorance about the moon. Meanwhile, every other civilization that figured out spheres, right? They figured out the Earth is a sphere, they figured out the moon was a sphere, and they had to explain why the moon changes. And every single one of them figured it must be an illusion, not an illusion, but an effect made by how light interacts. And most of these answers aren't correct, but they're on the right track, they're on the right line. But again, I need to strawman the argument of the ball version of, or the sphere version of the Earth in ancient Egypt, but that will be done in a completely separate video. I just want to make it clear why it's not obvious to anybody that the ancient Egyptians knew about a spherical Earth, which, by the way, would crush a lot of people's theories about how smart they were when it came to other things, like where they go crazy about they had drills, they had electricity, they had all of that. Not really, if they can't figure this out, this very simple thing that was figured out in many civilizations. I'll go back to a comment that I got about this, which said the ancient Egyptians were the originators. And I absolutely believe that. I believe that there's something about the way ancient Egyptians calculated these shapes, regardless of what they thought, that made it obvious to the people who studied their work, the Greeks, for example, and some other people, Persians and stuff like that, the people who studied their work, it became obvious to some of them that the earth and the moon and the sun and the planets, and in some cases they thought the stars, had to be spheres. Now, unfortunately, we have a lot of work missing. And of course, we have the Library of Alexandria, in which a lot of information was lost. Maybe not burned in a fire, as people claim, but some information was just lost from the Library of Alexandria. And a lot of this lost information might go arc back to the ancient Egyptians. And again, we have Pythagoras and people like that who made this assumption after studying in Egypt. They didn't prove it, but they made this assumption.